Hey, AP Chemistry. So I wanted to go over the worksheet with you, the one about naming the different functional groups and different organic compounds. I wanted to actually go through it with you and provide the answers so you know what you're doing. Hopefully the Khan Academy videos have given you a lot of new information about naming organic compounds. As you can see, it is extremely complicated sometimes, and frankly, there are multiple answers to what a compound might be called. Just based on the fact that IUPAC has a lot of different ways of naming things. The standard IUPAC naming, that is the conventional, that's the way it should be named, but there are also things that people add in that have just been kind of named because of tradition or something like that, like acetone, for example. Acetone wouldn't normally be called acetone, it would be called methanone, but people call it acetone because that's what we've called it for a long time. So let's just dig into the worksheet here. I didn't actually get a chance to print it off because my printer at home, it sucks, so it's not working, whatever. But I did go ahead and write everything out. So the first compound, it looks kind of like this. There's a methyl group and then a carbon, and the carbon's attached to the double oxygen and this hydroxyl group right here. The functional group that you need to identify was a carboxylic acid. So a carbon double bond to O, and then hydroxide off of that is a carboxylic acid. The next structure you see here, this right here, is known as an ester. You have a carbon with a double bond, and then that carbon is single bond to an oxygen, and then you have some other parts to the molecule that is known as an ester. And then this one right here, you have a carbon with a double bond connected to a nitrogen with things off of the nitrogen. That is known as an amine. And then over here, you have this red. I don't think that was part of the actual structure in the picture. You have a hydroxyl group in this compound. That's an alcohol of some kind. And then the last functional group is a halogen with the last picture. You have this bromine right here. The functional group is just a halogen. So these are just some of the functional groups that we have been able to identify. Carboxylic acids, amines, esters, aldehydes, stuff like that. So those should be getting into your brains. It's a little complicated, but with a lot of practice you can get it. Now the next part of the worksheet wanted you to, I believe, I want to make sure I did this right. It wanted you to draw the structure from the given name. So the given name propanol, propanol is an alcohol. How do I know that? I know that because at the end of the word is the OL, and that means that this is an alcohol. So when I read this, I say, okay, propanol, so that's going to be meth, eth, prop. Prop is three carbons. So 3 carbons and then the alcohol functional group off of the last carbon. If it had a number, we would be able to figure out where the alcohol of the hydroxyl group is exactly, but they don't give us a number, so I'm just going to assume it's at the end. So propanol meaning 3 carbons and then the hydroxyl group off of the end there. The second one, 2-butanol. This is again another alcohol. This time though, they're telling us where that carbon is, or where the alcohol hydroxyl group is. It's on the second carbon. Alex actually had a good question about this. It seemed like in the Khan Academy, Sal was kind of numbering the carbons randomly. There is no randomness to it. There is actually a method to his madness in the IUPAC naming system. So the number tells me what carbon that functional group is on, and when you are drawing that, when you're drawing the structure, you want to make sure that the carbon that you're talking about, well, this is the second carbon, and so I'm going to say, okay, this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. The functional group should always be closest to the start of the carbon numbering chain. So you can't really do it with this one right now, but if we numbered this differently, if we said 1, 2, 3, 4, well, and then you left the oxygen there and said carbon 2, well, that wouldn't be, if you said 1, 2, 3, that wouldn't work right because it'd be the third carbon, but it would be numbered wrong in that case. It would still, you'd want to correctly identify as 1, 2, 3, 4. So the functional group is always going to go on the earliest possible carbon to the start of the carbon chain. Your functional group will not go at the very end if it says it's 2 or something like that. You want to make sure it's in the right order. My little girl is running around. C. C is a pretty simple one. This is just an alkane octane, so you're going to have an 8-carbon structure. I just did it in the line structure here, so 1, 2, 3, 4, 5, 6, 7, 8. Every carbon has just hydrogen on it. D, 2-butene. 2-butene means that this is going to be an alkene. An alkene has double bonds in it. So being the second, saying 2-butene means that the double bond is going to be between the second and the third carbon. If it was the first carbon, if it was 1-butene, then that double bond would be between the first and the second carbon. But because it's 2-butene, it's telling us that the double bond starts at the second carbon. So this is carbon 1, this is 2, this is 3, this is 4. E, hexanoic acid. When I look at that, I immediately say, okay, I've got a 6-carbon acid, and it's going to be a carboxylic acid. So it's 6 carbons because of the hexane, and then acid meaning carboxylic acid. The carboxylic acid is going to be this structure right here always. And so 6 carbons, 1, 2, 3, 4, 5, 6, and then the hydroxyl group there and the double bonded oxygen up there. It didn't tell me where that carboxylic acid part is, so I went ahead and just put it at the end. That seems to be the standard method to the madness in general. So there's no number, let's put it at the end. For the next one is F, heptanal. Sometimes this would be called heptanaldehyde, so this is an aldehyde. When you see the anal part to the word, that makes me giggle. But anyway, you're going to say that's an aldehyde. So heptanal is a 7-carbon structure. So hep meaning 7, and it's an aldehyde. An aldehyde, remember, that is this kind of functional group. You have a double bonded oxygen to a carbon, and then off of that carbon is just a hydrogen. There's nothing else over here, but the other side of the carbon you have the rest of the compound. So heptanaldehyde, you're going to have 1, 2, 3, 4, 5, 6, 7 carbons, and then double bond oxygen, and then the hydrogen. G, propanoic acid. Propanoic, 3 carbons, and it's a carboxylic acid. So 1, 2, 3 carbons, double bonded oxygen, and then the hydroxyl group off there. H, 4-octanol. That is an 8-carbon structure, and then it's telling us that the hydroxyl group is going to be on the 4th carbon. Okay, so the 4th carbon has the hydroxyl group. And so I'm going to number it 1, 2, 3, 4, 5, 6. Did I not? 6. Oh, whoops, 6, 7. There we go. I can count. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons for octa, and then the 4th carbon is going to have that OH group on it. And then the last one here, I believe it's the last one, yeah, for that part, 3-hexanone. Hexanone, meaning that this is going to be a ketone. So on a ketone, you're going to have a double bonded oxygen to the carbon, but both sides of the carbon are going to have some other structure, not hydrogen. So it's a 6-carbon ketone, because I see the hex part, so 6 carbons, and 3 would tell me that this is the ketone functional group is going to be on the 3rd carbon. So 1, 2, 3, 4, 5, 6. Okay, let's move on. The last thing on the worksheet was just naming from the structure. Sometimes I think this is the harder thing to do. So the first question gave us this structure right here, and we want to identify what it is. First things first, identify how many carbons are there. There are 3 carbons, and then look for functional groups. The aldehyde functional group is right here. You have a carbon with a double bonded oxygen, and then a hydrogen off of it, and then the rest of the molecule is there. So this would be called propanal. Why propanal? Because there are 3 carbons. Prop is the prefix for 3, and then just an aldehyde, so propanal. You could call it propanaldehyde too as well if you'd like to. B, you have this structure right here, and we've got this functional group. The OH functional group is the alcohol functional group. There are 4 carbons, and that OH group is on the second. There's second carbon. not the third carbon. Remember, when we are numbering these carbons, we want to number the functional group closer to the start. So this is carbon 1, this is 2, this is 3, this is 4. So this is actually going to be 2-butanol. 2-butanol, not 3-butanol, it'd be the 2-butanol. So we're actually going to go the numbering this way. C, we have this structure right here. There are 3 carbons. So we're going to have some kind of 3-carbon carboxylic acid, because this functional group is right here. That's a carboxylic acid. And I'm going to call that propanoic acid. 3 carbons for prop, and then this is the carboxylic acid functional group, propanoic acid. D, this was just a carbon with a bunch of 5 carbons with a bunch of hydrogens around it. That's pentane. 5 carbons, there we go. 5 carbons with a bunch of hydrogens is pentane. It's an alkane, and there are 5 carbons. E had this structure right here. This structure would be some kind of alkene. It has a double bond in the center there. So there are 4 carbons, 1, 2, 3, 4, and the double bond is between the second and the third carbons. So this is going to be 2-butene. 2-butene. Moving on to the next. I'm going to use line drawings a little bit more because it just makes it easier to draw. I'm sure Eric is very happy about this. We have this structure right here. It has 4 carbons, 1, 2, 3, 4, and it's an aldehyde. It's an aldehyde because this is the functional group right here. We have a double bonded carbon to an oxygen, a double bond to the oxygen from the carbon with the hydrogen off to the side there. So this is going to be butanal, or butanaldehyde would be another way you could call it. Next one, this is some kind of methyl group. So it's got a methyl group off of the carbon in the middle. So this is a carboxylic acid. And then this carbon right here has the methyl group off of it. So this is known as methanoic acid. This is also known as acetic acid. Good old-fashioned acetic acid. CH3COOH. Everyone loves that. CH3COOH. I think I might have mislabeled it here. Looks like it's just 2 H's. Oh well. The next compound, we have this structure right here. And we have a triple bond right there. We have a triple bond between the first and the second carbon. So I'm going to number them 1, 2, 3, 4, 5. So 5 carbons and a triple bond between the first and the second carbons. So I'm going to call this 1-pentyne. 1-pentyne. It's an alkyne. It has a triple bond in it. The next one, which I'm going to call it H, but I think it's actually I. We have a carbon. We have another compound here, and it is a ketone. How do I know it's a ketone? I have this right here. So I've got that carbon with a double bonded oxygen, and then I've got a methyl group off to the side there. So this is a 4 carbons. Got 4 carbons coming off of the carboxylic acid and a methyl. Not carboxylic acid. 4 carbons coming off of the ketone with a methyl group on the other side of the ketone. So we're going to call this 2-pentanone. 2-pentanone. 1, 2, 3, 4, 5. Pentanone. Whoops. 1, 2, 3, 4, 5, 6. This is going to be hexanone. Whoa, boy. Is that right? Yeah, hexanone. Hexanone. So 2-hexanone. Why 2? Because that double bonded oxygen is on the second carbon. Here's 1, there's 2, 3, 4, 5, and 6. Sorry about that mistake there. So 2-hexanone. Then this would be called, yeah, you could also call it methyl-butyl ketone. Methyl group 1, 2, 3, 4. So you could call it methyl-butyl ketone as well. That would also work, but it's hexanone. 2-hexanone. So this is another way you could call it. You may have heard of methyl ethyl ketone, which is, I think, a pollutant of some kind, MEK. There's another way to name ketones as well, where you kind of name off the side branches to the ketone. But the IUPAC name here would be 2-hexanone, because there's 6 carbons. Okay, next one, we have an aldehyde. How do I know it's an aldehyde? We've got this functional group right there, carbon with double bond oxygen and the hydrogen off to the side. There are 5 carbons, 1, 2, 3, 4, 5, 6, and that's not pentanol. I seem to have lost my brain. This is going to be hexanol. Hexanol. There are 6 carbons there. So can't count. 6. There we go. I can count, but sometimes I make dumb mistakes. Okay, next one. We have a 5-carbon ring. 5-carbon structure, and we've got an alcohol, a hydroxyl group on the 2nd carbon. So this is going to be 2-pentanol. 2-pentanol. It's an alcohol with the hydroxyl group on the 2nd carbon of the 5. And I think this is the last one. Okay, last ones. So this is a ketone as well. We've got in the very center, we've got the carbon and then methyl groups on the sides there. This would be traditionally called acetone, but you could call it methyl-methyl ketone as well. I'm sure there's other names for it, but most people are going to call this acetone. Next one, we've got a long carbon chain, but we've got a triple bond between the 1st and the 2nd carbons. So it's some sort of hexine, and the 2nd and 3rd carbons have that triple bond, so we're going to call it 2-hexene. 6 carbons, hex, ene at the 2nd carbon to the 3rd carbon, hexene, 2-hexene. M, this is some kind of alkene. You've got a double bond there. And we're going to say that this is the 1st carbon because that double bond is closest to the 1st carbon there. So 1, 2, 3. So 3 carbons. The double bond is at the 1st to the 2nd carbon. So 1 propene. You could just really call this propene because people would assume if you say propene, you're talking about the carbon 1 to carbon 2 bond. Last one, or not the last one, second to last one, we've got a methyl group off of the oxygen here, the hydroxyl group. This is going to be some kind of alcohol with the methyl group there, so this is methanol, CH3OH. Last one, we've got a carboxylic acid, and we've got 1, 2, 3, 4. So 4 carbons, carboxylic acid, butanoic acid. Simple as that. So 4 carbons, butanoic acid. Hopefully it helps. Sorry about those little mistakes as I was doing that. I must have lost my brain, or maybe my little kid came in here and just goofed off and made me forget stuff. But whatever happens, it's okay. If you have any questions about naming these structures, please let me know. I'm happy to send a message back to you. I'm going to have a little quiz on this on Friday. So if you have questions about naming these structures or drawing them or anything like that, please let me know. I'm happy to help you out. We're pretty much at the end of the AP Chemistry material. So as the days go on, I'm going to be assigning review assignments, be giving you multiple choice packets, FRQs, that kind of stuff for you to work on so you're ready for the test, which, as you hopefully read in my message, is still going on. It's going to be online. I don't know any details beyond that. I just know that it's going to be online. For all I know, it could be something where, I know in some big testing situations that are online, they'll actually have a proctor, like someone will watch you while you are doing the test to make sure you're not cheating. Maybe they'll do that as well. I'm not sure. So as soon as I know, I'll let you guys know as well. So hope everything's going well. I wish you guys all the best. See ya.